Good morning, folks. My name is Michael Fulton, and on behalf of my co-authors, Junso Kong and Dr. Junaid Sattar of the Interactive Robotics and Vision Lab at the University of Minnesota Twin Cities, I'm pleased to present ADROC, an algorithm for approaching divers using monocular vision. Firstly, the task of approaching a diver with an AUV is a navigation task, which enables underwater human-robot interaction. The majority of diver AUV communication methods require close proximity between the diver and AUV, whether we're dealing with diver to AUV communication with gestures or fiducial markers, or AUV to diver communication with digital displays, robot gestures, and indicator lights. However, in the context of underwater work, AUVs may need to be far away from the diver, making communication difficult or, in fact, impossible. Therefore, when communication is required, it is preferable that the AUV have the ability to locate a diver, approach to an appropriate distance and orientation, and begin communication, rather than requiring the diver to hunt the AUV down. This is where our algorithm, Autonomous Diver Relative Operator Configuration, or ADROC, comes in. Using inputs from a diver detector and a body pose estimation algorithm, ADROC calculates the position of the diver relative to the AUV, including the distance between them. Using this diver relative position as an error term, we use a PID controller to manage the robot's motion, controlling thrust and orientation to bring the AUV to the diver. A state machine manages the overall algorithm, switching between a searching behavior if no diver can be seen, the approach behavior once a diver is visible, and terminating the approach once the AUV is stable at an ideal position and distance for communication. As previously mentioned, to approach the diver, we must know their position relative to the AUV, including the distance between them. Estimating the orientation of the diver relative to the AUV is simple. Detect the diver and move until they are in the center of the frame. Distance, however, is more difficult. Most methods of estimating distance between an AUV and a diver would require specific sensors such as sonar, stereo cameras, or indeed accurate localization of the AUV and diver in a known global map. However, we were interested in creating a diver approach algorithm that any AUV could use, so we asked the question, is it possible to determine the relative position to the diver using only monocular vision? The key realization we had was that we didn't actually need to know the exact distance, only how closely our current distance matches the ideal distance for communication. By using prior knowledge of the typical shoulder width of a diver, we can calculate a ratio between the current distance and the ideal distance based on how wide the diver's shoulder appears in an image. We calculate this ratio, called pseudodistance, in a cascaded manner from both bounding box and body pose estimation input. From bounding box information, we calculate pseudodistance by using the width of the bounding box as a stand-in for shoulder information. And with body pose estimation, we can use the actual distance between the diver's shoulders as our input. This method can be applied either with the typical shoulder width of an adult from biomedical literature, or it can be tuned to a specific diver's actual shoulder width, which may differ from calculated averages. This video demonstrates how ADROC enables an AUV to approach a diver. Here we see the local AUV approach my co-author Junso Kong, then back off as it has gotten slightly too close. The AUV can be seen in the third-person view on the left, with the robot's eye view on the right. To evaluate ADROC, we tested approaches in 162 different trials with 9 different divers in 2 different pools and a variety of distance and angle setups. ADROC successfully approached divers 81% of the time. Thanks to all our collaborators, colleagues, and funding partners. And if you are interested in further information about ADROC, please go to this link, tinyurl.com/IRVADROC.